Good morning, I am Mr. Ish. Thank you for joining me. We are having here a continuation on this topic on binomials, the binomial theorem, binomial expansion. We have x minus y to the power of 7. We have to expand this to demonstrate the first three terms. When you see this exponent over here, this exponent here indicates your n. When you expand it out, you'll always have n plus 1 number of terms. So you will have 8 terms, but we're only focusing here on the first 3 terms. I will show you the technique. And you always have to remember this specific formula, NCR. These are your coefficients which will come before each expanded term. NCR, n factorial over r factorial, n minus r factorial, and you have to bring that into play. We will look everything here in a methodical manner. The very first term, you're going to always have in the sense NR, and then you'll expand from there. So rather than me spending too much time over here, let me just show you the rough template, and it looks something like this. You start with something like this and then you continue. You're always decreasing this first quantity by a minus 1 as you go this way, and you're always increasing this by a plus 1. That's how the technique will work. So let me show everything here with the actualities we have over here. We will have a 7 and then an r, which here will be a 0. This will be our first term, 7, 0. Then we'll have x, 7 minus 0, which is a 7. And then y to the power of 0, and then we will not worry about the signs just yet. Then the next term, we have a 7 and a 0, 7 and a 1 now. You're adding here r value by 1, and that will automatically adjust everything here for everything which follows. This is n minus r, 7 minus 1 will become a 6, this will become a 1. You see how the 7 has become a 6, but a 0 has increased by 1? That's exactly what you see. So 7 and a 2. Here you'll have a 7 minus 2, which is a 5. Here you'll have your r, which is your 2. But everything is going down by 1s in terms of your x, but everything is increasing by 1s in terms of your y, the exponents. Now when you have a minus here, you start with a positive, and then you just alternate the sign, and that's exactly how things will play out. Everything over here, x to the 7 will stay as is. Here we have x to the 6 and y. Here we'll have x to the 5 and y squared, but we need to bring in the coefficients. You know the formula. This right here will zero out in the sense that you'll have a 7 factorial divided by 7 factorial. Zero out, it means everything will cancel out. You just have x to the 7. But here you'll have a 7 factorial over 6 factorial, 1 factorial. The 6 factorial will cancel everything after the 7, leaving only the 7. And that's what you'll see here as your combinatorial coefficient. Here you will see a 7 factorial over 2 factorial and a 5 factorial. The 5 factorial will cancel everything from 5 onwards, leaving here only on the top 7 times 6 and a 2. You can do this all on the calculator. But 7 times 6 is a 42, divided by 2, you'll have a 21. And that right there would be your first 3 terms. But we can do this part here again. You'll do a 7 factorial, which is 5040, divide that by 2, divided by 5 factorial, which is 120, and you'll get 21, and that's exactly what we're seeing here. But everything looks right. X to the 7, 7x to the 6y, and 21x to the 5y squared. And you can see the signs, positive, minus, positive. Those are the first 3 terms, and this question is completed. Our second question is where we have to find a specific term. You've seen something like this before, but this is just extra practice. Again, our n value here is 6, so we know if you were to expand this out, you'll have n plus 1 terms, you would have 7 terms. But we're focusing here on the third term. You would use over here n minus 1, but this n over here relates to something different than that n. We're just using an n over here, n minus 1. This is your nth term. You do n minus 1, so you're really looking for term 2 in terms of your r value. And you know you have a formula which looks like this, nr, and then you have your x component here, which has a coefficient, and you'll have an n minus r, and then you have a y component here with its coefficient, and then you have an r. All you gotta do is bring everything into play. We have n value here of 6, r here is a 2, we've demonstrated that. Your x component here is all of that with its coefficient. You'll have n minus r, which is a 4. Then you'll have your y component, which is a 3y, and then you have just the r, which is 2. You have to expand all of this out, and you know you're going to do, for this portion right here, you'll have a 6 factorial over 2 factorial, 4 factorial. And then you're going to multiply this product here with this and that. So let's do this. We'll do 6 factorial, which is 720, divided by 4 factorial, 24, divided by 2, we'll have a 15. From here we're generating a 15, from here we're generating a 16x to the 4, and from here we're generating 9y squared. So we have to multiply all of these. 15 times 16 times 9. We have a value here, 2160 x to the 4 and y squared, and this right here is your final completed answer, and it looks good to me. So remember what you've seen over here. We can always do more of these if you want. You can request in a comment that you want to see more of these type of questions and I can show you more. But that's it for this video. Thank you. Have a great day. Bye.